Now that we have discussed about the angle properties in a parallelogram, now comes the question on how do we connect the properties of a parallelogram connected with its diagonals. Today's session is about the diagonals of a parallelogram connected with its own respective properties. Properties connecting the diagonal. Diagonal properties in parallelogram. Let's consider a parallelogram with its respective diagonals. So here I have a parallelogram A, B, C and D. So clearly we know that the opposite sides are parallel and of course equal. For this parallelogram we have two diagonals as discussed in the previous session. So one of the diagonal is obtained by joining AC and the other diagonal is obtained when I join BD. So here my diagonals are AC and BD are the diagonals. Now let's see what is the property which connects these two diagonals. Before this, I clearly understand that diagonal AC intersects diagonal BD at say some point M. So I clearly have a point of intersection of the two diagonals as represented by M. So here my M is the point of intersection of the two diagonals. So M is the point of intersection of the two diagonals, diagonal AC and diagonal BD. So let's see the property connecting the diagonal property. The property says that the diagonals AC and BD bisect each other in a parallelogram. This is one of the most important property in the parallelograms because bisecting concept helps us in solving many mathematical problems. To come with the property, diagonals bisect each other in a parallelogram. What do we mean by bisect? The word bisect means cutting at midpoint. That means the diagonal AC, say the midpoint or the middle point exactly of the distance A and C is M, then clearly the middle point of BD is also said to be M. It's how we understand bisecting each other. Bisecting each other in the sense the midpoint of AC must be the same as midpoint of the other diagonal BD. So therefore, when the point of intersection is this, I understand this equals this and this equals this. Is how the bisection is understood in parallelogram concept. Diagonals bisect each other in a parallelogram. Therefore, AC and BD bisect at point M. That is, M is the common midpoint for the diagonal AC and the diagonal BD. Is how we understand the bisection. And using this property, M bisects AC and BD. That is, more simpler understanding, M is the common midpoint for the diagonals AC and BD is how we understand the diagonals bisecting each other. Diagonal property: diagonals in a parallelogram bisect each other is how we understand through the parallelogram A, B, C, D. Now that we have discussed about the diagonal property in a parallelogram, now comes the discussion of converse. Will the converse be true? That is, if the diagonals in a quadrilateral bisect each other, will the quadrilateral form a parallelogram? It's the biggest question in converse. So let's investigate the converse of the session. Diagonal property. Parallelogram converse. So let's see the converse of the previous session. Imagine I take a quadrilateral A, B, C and D. So I have a quadrilateral formed by 4 lines in the closed region A, B, C and D. Let's see the property connecting the converse. Now imagine I take the 2 lines joining AC and BD out here. Now if the diagonals bisect, that is, if the diagonals meet at the common midpoint, then will this shape be a parallelogram? Yes, it will be. That is, the converse holds for a quadrilateral where the diagonals bisect each other. So let's see the statement of converse. The converse statement says, if the diagonals of a quadrilateral bisect each other, then the quadrilateral will form a parallelogram. Yes, the converse of the previous session holds. If the diagonals of a quadrilateral bisect each other, then the quadrilateral must form a parallelogram. They must form the pair of lines which are parallel to each other, is how I understand the converse of the previous session. Therefore, in this case, M bisects the diagonals AC and BD, implies M is the common midpoint of the diagonals AC and BD, and that implies quadrilateral ABCD reduces or forms a pair of parallel lines. Quadrilateral ABCD forms a pair of parallel lines, this being parallel to this and this being parallel to this. Therefore, quadrilateral ABCD is now called a parallelogram. Now I can call my quadrilateral ABCD to be a parallelogram. Therefore, the converse. If the diagonals of a quadrilateral bisect each other, then the quadrilateral must be a parallelogram. Is how we understand the concept connecting the converse.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.